about three things that usually are tackled by different people and require different practices, but actually they constantly touch each other. Architecture, structure of the development team, and infrastructure, the deployment infrastructure. So, I'm going to touch on a variety of subjects, just little touches just to explain what I mean by the terms I'm going to use, and then I'll get into that funny little triangle that I drew on my top slide. By the way, since usually people ask, the slide is on the top of this page. So if you can remember how to spell my first name, which is a bit challenging, and my last name, which is very challenging, then you can find my slides. So I'm going to speak about what is architecture, what's an architect, is there any rhyme or reason to use the word agile and architecture in the same sentence, or is that a total oxymoron? There's a lot of concern by many companies about scaling up agile to tackle bigger stuff. So I'll be speaking after that of some relatively complex stuff like social-technical congruence, which is a fancy word to sort of say we need to have the people and the stuff that we do with the people relatively well aligned. And then things that have been touching our industry over the last 10 years, which is more frequent delivery evolving to continuous delivery. And then there's this new thing that a lot of people are looking at, like what's that strange piece called DevOps? And I noticed on the program that somebody was speaking about DevOps, probably in this room, probably just while I was teaching some undergrads at UBC, but okay, I missed that. So we can have a beer after that and agree to disagree on what DevOps means. This is something that is external knowledge to me. I've never been in an organization that was doing DevOps. And I'll conclude by a few reflections on how do we reduce friction. So what is architecture? There's many flavors of architecture. The word architecture is used in different contexts. You see system architecture, enterprise architecture, solution architecture, application architecture, information architecture. So there is a business aspect that looks more at the processes, the workflows at the level of the organization. So there's probably a business architecture. Business analysts are immersed into that. This is actually a definition extracted from the BABOK, the business analyst body of knowledge. So there's enterprise architecture. Same thing, comes from the BABOK. And then that's to tell you what I'm not going to speak about, but it has some bearing on what I'm going to speak about, and I'm not an enterprise architect, and I wouldn't pretend to be one. That's the world I come from, system architecture, software architecture. You hinted at some of the system I've been working on. I worked on telephone switches at Alcatel for 8 years. I worked on submarine, like the A-19 submarine in Sweden, and Collins class submarines in Australia, on air defense systems for Iceland and Taiwan. And then the reason I came to Vancouver initially for 3 weeks was the Canadian Air Traffic Control System, where I met a few people that are part of this organization. But the 3 weeks became 3 months, and then another 3 months, and then another 3 months. And 5 years later, when I told my kids, that's it, we pack back and we return to Europe, they had turned into teenagers, and they say, no, Dad, sorry, we stay here. So, hey, here I am. There are certainly around the world the word architecture to sort of two main cultures. There's the enterprise architect who have their own jargon and reference and conferences and books and publication and terms that they use and heroes and gurus. And there is the solution architect, and I'm more the left-hand side for you there. So enterprise architects tend to act as consultant advisors for the whole organization. They are more into building bridges between various organizations, whereas solution architects are more focused on doing the thing, building the building themselves, not just the bridges between the various islands. And they use different reference models. On one hand, we speak about things like architecture reference model and things like that. People use processes that are relatively close to system development, software development. On the other side, there are things like architecture framework like TODAF and TOGAF and all kind of good stuff. The three things, system architecture, software architecture, and enterprise architecture, they're not totally separated. And there is a reason we probably use the same term, and there's some interesting overlap, and this overlap may be different in different contexts. Then, just to be complete, the word architecture is also used to designate a certain type of architecture. So when I say layered architecture, or client-server architecture, or service-oriented architecture, or microservice-oriented architecture, I'm speaking about a certain pattern, a certain way of organizing the architecture of a system. So this is using the word architecture, not like solution architecture or enterprise architecture. This is more concrete. So what is software architecture? This is something that over the last now 25, almost 30 years, I had tried to evolve a definition. This one is my follow stuff. It's the hard stuff. But when we challenge him, say, well, yeah, what do you mean by the hard stuff? It's the stuff that will be hard to change later. Okay, so it ended up being some of the stuff that in an ideal world you have to decide relatively early, not on day one. If you decide all your architecture on day one, you're probably going to shoot yourself in the foot and regret it bitterly 3 months later or 3 years later. But it's certainly the stuff that will be hard to change. Over the years, I've worked with 2 standardization bodies on trying to better define what architecture is and how to represent it and how to communicate it to different audience, to different stakeholders. Our first effort was inside IEEE, and we created a standard called 1490, if I remember, or 1470. But this was rapidly followed by an effort to standardize at the level of ISO. And we've had now a second revision of the ISO standard. Curiously, coming together with people from around the world on how to describe architecture, what are the conceptual models, the elements in architecture, we got to that relatively rapidly. Remember, the standards exercise are an exercise in compromise, not an exercise of who wins. There is no competition. So the standards sometimes are a little bit weak because of this effect of compromise. But curiously, and interestingly, the one thing that took us the longest time to agree on was that one little paragraph on the definition section, what is architecture? So we end up with something that I'm not too happy with, but okay, you have to compromise with the Brits and the Germans and the Japanese and the Russians. So this is what we ended up with. I still very often go back to the definition that we had put in the RUP, the Rational Unified Process, which is still a product of IBM. The Rational Unified Process, many people in Vancouver do not know, but it was developed in Vancouver entirely. It was developed on the 6th floor of the Oak Ridge shopping mall, which we occupied at the time. So what is software architecture? It encompasses significant decisions. So this is about design. This is not about requirement and technology and things like that. This is about making significant decisions about what? About how do we organize the system? How do we structure it? What are the key interfaces between the chunks? What's the behavior of those chunks? Very often architects stop at a static definition of architecture. Architecture at the what I would say the compile time level. We also have to look at it at the runtime level. And some of that lack of focus on the runtime is what is going to create some issues that DevOps try to address. And then for large complex systems, when we speak million lines of code, few things are into subsystem, and the definition can apply recursively when we go down. But the definition is longer. There's issues of style. We want to have an architecture that is easy to communicate to other people, So there's a certain uniformity. You don't want every single designer to impose its own style. Pretty much like, you know, in buildings, we like to have some form of uniformity and regularity. And then architects are very concerned about other things than just the technology, but all kind of fits. You know, it has to satisfy some constraints, economic constraints. It has to be understandable. Architecture is, sure, the system has to deliver functionality, but the main concern of the architect are in the utilities, the adaptability, testability, scalability, evolvability, performance. Okay, this one doesn't end in utility, so maybe we should create a new word in performability. So there's a lot of trade-offs there because there's a lot of constraints. So it's not we can design the perfect architecture that will survive the next 25 years or beyond. So the people doing that are sometimes called architects. So I had on my business card the title of architect for about 20 years. I started at Alcatel, but I had very little clue what that meant at the time. There was no book about system architecture, but okay, we thought it would be nice. So there's roughly two parts in the job. There's a part which is defining the architecture, making some of the key choices, choosing the appropriate technology, evaluating the architecture as we build it iteratively, and evaluating it sort of objectively in the form of some key metrics or tests. As I said, there's a lot of things that are driven in architectural decision by the utilities, the quality attributes that matter for our system. And the quality attributes, no offense to business analysts and product managers, they're usually not that clearly expressed in the requirement. You know, you get these big sentences, and the system is user-friendly, and the system works 24/7. What does that mean, 24/7? By the way, 24/7 is extremely expensive. I worked in telephone switches. We had, 30 seconds downtime per year on average over the whole population of switch. So you cannot stop the system for 2 hours to replace a card or reload the software. You do the maintenance on a live system, electrically live. You pull out boards. So, but this is extremely expensive. Multiply the cost of your software development by a factor 10 to achieve. And some switches, the ones used in some circumstances like emergency services and things like that, the downtime is 5 seconds per year. Anyhow, so managing the non-functional requirement is usually something that is done with much more involvement of the architect than business analysts. And architecture also is the platform for collaboration with other partners. Nowadays, many systems are built in a sort of ecosystem, so you have to interoperate or buy software or services from other teams, and the architecture provides the right platform to have this discussion and negotiation. And then some architect thinks that the left-hand side is it, and when the left-hand side is done, they can move on to the next consulting engagement or the next project or whatever. Actually, there is also the delivery of the architecture. I'm in the opinion, and it's not shared necessarily by the whole community, that we should be like the architect that designed your house. We are implied until the day you can actually move on. We cannot just say, here's the blueprint, good luck with the construction. So things evolve, things changes. So there's this, owning the big picture of where we're going to go in the future. And because the architects very often have a little bit more experience than your young grads that we threw out to you from UBC, they play a role in coaching and mentoring, at least on the technical design side. They have to get involved in testing. I see people say, oh, testing, there's a QA department that takes care of that. They add testing at the end. Actually, large complex systems that have a high availability and performance issues, a lot of software is built inside explicitly to facilitate testing. If you want to test a safety critical system in all kind of circumstances, those circumstances are hard to simulate from the outside, so you want to inject certain type of defects from the inside. Therefore, you need to instrument the code to be able to trigger this or that defect. So architects have to communicate with what the software industry call quality assurance, which other industry call quality control. I think that quality assurance is a different function than quality control. Okay, I'll go with the flow there. So architects, I'm not saying this is an org chart for an organization, I'm not that arrogant, but architects are at the sort of communication vertex of three main constituencies there. You know, business analyst, product owner, and things like that. Architects have to understand and elicit and push back on what it is that we build. They have to communicate with various developers, which may be scattered across 6 or 7 time zones, and they probably will speak another language. The level of the discussion is at another level, and they need to be soldered at the hip with project managers. When I was living in Europe, I would use the church and state separation analogy and what happened in Europe over the 19th century. But in North America, I use the Hollywood metaphor. When you do a movie, there's a producer and there's a director. And they have specific responsibilities. But they cannot do their own thing unless you're Cecil B. DeMille or whatever. You cannot just say, oh yeah, well, I don't like the site there. Let's go somewhere else. After the producer has made sure that you have all the actors and all these little vans that we see in Vancouver regularly at various intervals, and all the caterers and all the lights and things like that. So they have to agree on each other stuff. They have to speak to each other relatively regularly. So this is just a little bit of a caricature. The analysts, by that I say, is different stakeholders that have some goals, some requirements, and some constraints that need to be satisfied. They don't necessarily speak the same language. And the good architects are people who are actually able to dynamically adjust the level of language and the level of details with which they speak with them. And developers on the left-hand side, maybe there's multiple developers, maybe there's some technology vendors that you deal with, something like that. And here the dialogue is again at another level. So, around 2003 and 2005, when that strange things called Agile started to appear on our radar, a lot of people said, oh yeah, well, we're Agile, we don't need any architecture. Look, Ken Beck, book, he said, you just need one nice metaphor to explain how the system works. Going even further, there's principle number 11. The best architecture will gradually emerge out of weekly refactoring because you have a self-organizing team, which is a pretty strange principle. It looks more like a mantra. If I repeat it, it's going to get true. I could never figure out the connection between the self-organizing team and the fact that it will lead to the best architecture, and certainly I've never seen any evidence. I'm willing to believe that you may have a self-organizing team, and they may have a pretty good architecture. So there's been lots of debate, and we had some healthy one here at Agile Vancouver around 2005, 6, 7. I'm one of the co-founders of Agile Vancouver, hence the remark of, what's that? Sorry. Suzanne next door. But okay, I've done my 5 years on the board, so, and I don't, 8 o'clock Thursday morning is too early for me. So there's clearly a tension. There are all kinds of systems, including the systems where I had a long lunch discussion with Ken Beck in Montreal a few years ago. The kind of system where he worked when he developed XP had a stable architecture. They were adding a lot of code and a lot of functionality, but they had a relatively stable architecture. They didn't have to decide about how was the system organized, how was it distributed, which programming language to use, which database and things like that. Those decisions were already done before you arrived. So the notion of having simply a metaphor made sense. On another hand, 6 or 7 systems in which I worked, there was no de facto architecture. We had to do a lot of upfront work to select the right technology and invent, in some cases, new things. I even hold a patent on some architectures. Well, I'm just the inventor. The assignee is big use electronics. So I think this strange tension that occurred between the agile world, oh, we don't need any architect, oh, awful, something from the past. It's mostly the same phenomenon that we see again and again. How much can we anticipate and how much do we need to adapt? If we can constantly adapt, then we don't need to have a lot of anticipation. And what is architecture, architectural design? It's basically anticipation. You need to anticipate on future needs. So many projects, small projects, there is a de facto architecture. From an architectural perspective, you just need to continue to adapt, but you don't need to anticipate a lot. On the other hand, some relatively novel system, you may need to have to do a lot of anticipation. And the same thing can be applied to process. You know, how much anticipation versus adaptation. If you're working on safety critical systems, on systems that needs to be certified by the FDA or the FAA or TÜV in Germany and Europe and things like that, there's much more anticipation that you need to do. You cannot just do some quick adaptation dynamically as you would do if you just, you know, sell some web-based app or some iPhone apps. Okay, so Agile is here to stay. We used to joke in the committee a few years ago about being post-agilist. There's still some issues. A lot of people have, you know, developed a good feel for some of the good practices that were developed over the last 12 years. And if Jim Brosseau was here, he would tell you that they were developed long before they just became visible in 2000. For what I call the sweet spot, the 6 people collocated, iterating at the rate of 1 iteration every week or every 2 weeks, and with a stable architecture, no problem. You probably don't need to do a lot of effort on architecture. One of you with a good skill for design will tweak the architecture and doesn't need to have the word architect on his business card. But people have tried with more or less success to scale this thing. Say, oh, can we do it with? Okay, I was on the phone just a few days ago with a vice president of Ericsson, and just to understand what he was describing, I asked him how many developers do you have? He said 1,200, and they're on 7 sites in 5 different time zones. And they want to be agile. Actually, they say, oh, all the team are doing Scrum, but at the level of, okay, they develop the base stations. The base station is basically the thing that your cell phone speaks to, okay, with little antennas, but there's a box below the antenna usually. So how do you do Agile when you're 1,200? Okay, I've never seen a team that large actually. They're broken down in multiple teams, but it's still one product. So larger systems, larger teams, distributed teams, that's pretty difficult, more frequent release over longer time frames. So we're speaking about product that you don't develop and 2 years later throw it away and go and do something else, because that software represents a tremendous asset, you know, in terms of financial asset. So for the last 5-6 years, a lot of discussion were about how do we scale agile practices to more challenging projects. So that's where we had discussion about Scrum of Scrums and all kind of things to try to stretch the practices that felt pretty good and were pretty effective in a small team, the sweet spot. How can we do that when we're not in the same office? How can we do that when, okay, my team, the one I was describing earlier on, half of it was in Oak Ridge Shopping Mall, the other half was in the suburbs of Stockholm, in the Swedish Silicon Valley, called Kista. Well, you know, it's difficult to have, you know, something looking like a daily stand-up meeting when, you know, I had to wake up at 5 a.m., you know, go to Oak Ridge with my mug in my car, and they were, you know, Philippe, I'm sorry, we have to go to the kindergarten, otherwise we get fined. So, yep, there are practices where people have found ways to scale them up. if Steve Adolph was here, he would tell you that the scaled agile framework is the way to go. Yeah, my former colleague, Dean Leffingwell, who worked with me at Rational Software, has developed a good set of practice trying to do agile in a larger context. But I think in some ways it's not really the real problem we have, scaling practices that work with small teams to larger teams. I think it's not a goal in itself. It may be a means, but I wouldn't spend too much time trying to scale up stuff. The kind of problems that I see, not at UBC teaching with undergrads, but in the other part of myself that still do some consulting, people want to develop architectures that are capable of supporting multiple waves of enhancement. So this is the long-term aspect. To accommodate a sort of constant flow of new needs. So if you develop an initial system very rapidly and take a lot of shortcuts on your architecture, you may end up having a product version 1 that's pretty successful, works pretty well, but dies between version 1 and version 2 because it's extremely hard to evolve. And sometimes you have no choice. You're limited by the amount of money the venture capitalists are willing to throw at you, and they want something, and they want something quick. So that's where we take a lot of technical debt, relatively technical debt at the architecture level. I'm not speaking about technical debt about crappy code that works but is not nicely done. I'm speaking really making some of the architectural choices. So another issue when you try to work on a relatively large new system, and nowadays with a lot of teams that are distributed, do you have an architecture that allows you to work as if each of the teams working on it works in an agile fashion, but they still work on a single system? So is the architecture facilitating this in some ways? And the other thing, as we want to make software available to the user more rapidly, and we have the tools and techniques to do that, can we avoid the extra work that is generated by throwing the code over to the operations people, which is still the main way of doing things. There is the R&D team under the VP of R&D or whatever title he has, and then when the software is ready and tested, it's given to operations, and operation will figure it out. And the software developers go to Whistler now because they're done with their release, and the operation people say, and there's nobody we can speak to, and the whole thing is crumbling apart, and who are these developers? And the developers say, and the operation people, they don't know what they want, and this was not in the requirement, or it works in our test environment, so it should work in the operational side too. So that's the kind of issue that I see. There's other issues, but this is for a totally different talk. The hardware people have outpaced the software people, and we have massive multi-core system, and we don't know how to develop software for massive multi-core system and exploit it, especially when it's legacy code. But this is for some other day, if you invite me again on the night. So, in other words, can we have some kind of agile architecture? When people say agile architecture, there's an ambiguity. Are you speaking about, is the architecture agile enough to evolve rapidly over time? Or are you speaking about agile architecting? The way we develop the architecture is an agile way. We do that iteratively with a lot of communication between people and a lot of trial and errors and small iterations. You can have an agile architecture even if you're not an agile shop. You could be totally waterfall and end up with a very agile architecture. Actually, there's been an example of that. Sabre, the airline reservation system, was not developed with an agile process, but it ended up being a pretty agile architecture. It's probably one of the oldest massive amount of software that still runs and do good service. Doing two, if you're relatively agile and evolve an architecture, you may end up with a relatively rigid architecture. So don't imagine that because you've stuck the two words together, the way your process works will lead to an agile architecture, or that an agile architecture is necessarily the consequence of being agile during its development. So scaling system up, bigger system, larger teams, more requirements, distributed system, need architecture. And this is a message that was sort of briefly forgotten by the Agile community, but that has come to take back some of its significance. Work partition, decoupling things, removing or reducing dependencies so that small groups of people can work more independently from each other, especially if they're scattered across the globe. Architecture can serve all kind of purpose in terms of, guiding release planning and configuration management, addressing the major entities. You can maybe confine most of them at the architectural decision level and not have all kind of entities scattered around. Performance maybe and security may be an exception to that. Those have to be concerned all across the software. They cannot be encapsulated somewhere. You cannot say, oh, this subsystem is taking care of security, because security, you may have some buffer overflow over there. Other issues that large organizations have tackled or had tackled and then fell back a little bit are, how do we systematically reuse software? Systematically, not accidental scavenging stuff, downloading some open source thing. Systematically reusing it. One of our customers at Rational, still a customer of mine, Philippe in Eindhoven, has a product line of medical imaging systems, X-ray stuff, MRI, CAT scan, whatever. They have a policy of very, very systematic reuse. For a new system, up to 90% of the code is modules that they've reused out of their repository of code for MRI systems, for instance. And they only add code when they have new interfaces or new device or something like that. Some divisions of Siemens, same thing. They have a very, very systematic policy of reuse. Now, I'm saying this is becoming an acute problem. We've accumulated over the last 20 years a lot of code. A lot of this code still runs. So half of our workforce in IT software development is used maintaining software, about half. That's the number that I have for Germany, and I think it's the number we have for the US. I have no numbers for Canada. So the labor gap is increasing. Roughly, it takes one software developer to maintain 80,000 lines of code if you have a 10-person amount of change on a yearly basis. So this we knew for a while, about 15 years ago, and a lot of that gap has been absorbed initially by India and then by a few other countries who sort of say, oh, me too, we also speak English here, send us your software to maintain. But even that is saturated. So we as an industry will have to face it. We cannot continue to generate relatively large complex systems that are brand new and will need to be maintained. We will have to change our strategy and go the SAP route, for instance, have semi-standardized modules and components that we can just configure and have the most of the added value in the configuration and the deployment, and not in rewriting the same code again and again every 5 years in another programming language or on another framework. But okay, this was a little digression. The labor gap is increasing, and a lot of people, especially the one I was teaching just 2 hours ago, they'd like to develop new software. They don't want to be stuck the rest of their life doing maintenance on that 2 million line of code that was written before year 2000, or just after. Okay, so the concept of reusing things in a systematic fashion, the concept of product line, this is where architecture plays a big role. This is not a matter of being agile and doing a daily stand-up meeting and having Scrum Master and all this good stuff or pair programming. This is about making certain choices both in the technology and in the process that you have in order to be able to reuse software in a systematic fashion rather than just running from one technology to another one and rewriting stuff. So I claim that scaled Agile benefit from having a healthy focus on architecture, and actually I advocate a lot of companies to have an architecture owner pretty much like they have a product owner beyond a certain level of difficulty or a certain size. Doesn't need to be the full-time job of somebody. That person can have other roles in the team, but somebody needs to own the architecture decision, make sure that the architecture will emerge, drive that emergence. It doesn't emerge by accident out of a matter of weekly refactoring. But architecture also benefits from agility. For me, agility, the two tenets of it, the two basic principles is do things iteratively and reflect on what you've done at each iteration, whatever is the level of this iteration. So do things in small increments. Pace your decision, drive them driven by risk or unknowns. We need to do this in this iteration in order to resolve this unknown. The other aspect of agility is communication and collaboration. So speak to each other, even if you're not in the same time zone, find ways to communicate. Don't just write documents that you're going to ship over the net to other people for review after 6 months. But the iterative aspect is key. Architecture is not one phase that comes before we start doing software development in between requirement analysis. It's relatively constant. If some of you may remember that old thing called RUP, it's in that elaboration phase where we start solidifying this architecture and testing it. Architectural elements, very early, they can be stubbed. You don't need to develop everything up front. You need to identify the things that will need to be developed so that you can identify the interface and you can actually partition the work. So architecture can help large-scale agile projects. There's some hints of that in the scaled agile framework, but it's not explicit enough in my opinion. So I've had discussion with Dean Leffingwell on that. So architecture also brings a common vocabulary across multiple parties involved, inside and sometimes outside of the organization. A common culture, some stuff that we can recognize and build this common mental model of what it is that we build, how is the system designed, who's doing what. Maybe this is what Ken Beck had in mind when he spoke about having this nice metaphor that allows you to communicate to any new party arriving in your team. What is the structure, the architecture of the system? Control dependencies. Dependencies is the thing that degrades very rapidly. Create more and more dependencies. Not just dependencies between that piece of code and that piece of code, but dependencies between people, dependencies over time, dependencies on external stuff. And one of the key concerns of the architect is we cannot eliminate the dependencies, otherwise our system would be some little islands that would not be connected. But we need to keep the dependencies to a minimum. Part of that will allow us also to keep technical debt in check. And again, it's technical debt at the structural, architectural level, not technical debt at the level of small imperfections scattered throughout the code. So there are trade-offs. Is architecture done upfront or is it an emergent property of the system? The answer is neither one or the other. Yes, for reasons that are obvious. Remember Martin Fowler's definition. It's the hard stuff, the stuff that will be hard to change later. Yes, a lot of it has to be relatively early in the development cycle. Is it emergent? Yes, it's emergent if somebody makes it emerge. It doesn't emerge just by accident. So somebody has to make it emerge by pointing in which direction it needs to emerge. So there's all kind of motto in the Agile world. Defer decision to the last moment. I forgot how it's phrased. Yeah. Yep. Yep, but sometimes the last moment that you think is the right moment, it's a bit late. Because when you make that decision, it has dramatic impact on all kind of other things. So finding that right moment is a pretty difficult thing. So how much can you defer? On one hand, you don't want to build a super deluxe architecture that does everything for everybody for the next 3 years up front. But you need to build enough and have identified enough of it to proceed with your immediate goals and be confident that you can actually evolve it later on. So architecture is really an integral part of development. There's still a few companies out there where the architect are a bunch of people my age that sit in some other floor, some other office, or some other building, or in one case in another city. And I know that because when I speak with the developers, they say, oh, architect, we have some. Aren't there the old farts that live in... Okay, I'll skip this one. So we will not do just architecture at the beginning, or we will not just start rushing into some development and showing some user value right from the first iteration, as Mr. Ferdinand would advocate. We'll have to interleave doing some architectural work and some non-architectural work, maybe user-facing, and interleave them iteration after iteration. And maybe you can alternate between iteration or do them with 2 teams working in parallel and synchronizing every week or every other week. But it's not like one team is going to go off on the mountain and come back 6 months later by, oh, and we have the architecture. Oh, but we've already piled up 400,000 lines of Java code. We don't need your architecture. We cannot retrofit it from below. And you're laughing, but I've seen a project going exactly that route. So we need to interleave this focus on the architectural element and putting the architecture in place over multiple iterations and putting what I call the green stuff, or the functionality, the user-facing stuff, the features, if you prefer. This way, we can actually see an emergence of architecture. It's deliberate, it's not accidental. And again, somebody may want to own this decision. Not necessarily make them, but own and know which decision we have to make and collaborate with the rest of the team so that the decisions are made in due time. We can also validate the architecture with real functionality, not just hypothetical stuff. And we need to have enough in place of the architecture to support the development, even if it's stuff that is stuck. You may not have the deluxe distributed database. You may just have one copy of MySQL at the beginning. But as long as you know where you're going to go, you can substitute that at some later iteration. You don't need to make all the decisions and get all the pieces in place before you can actually start development. So a lot of the criticism that I heard as a software architect on architecture is, oh, we are agile, we don't want any big upfront design. Yes, but architecture is not necessarily big upfront design. It can be designed, it can be paced over multiple iterations. And Yagni, that's another thing, you ain't gonna need it. Yep. But when you discover very late that you need it, or if you ignore the fact that you need it, when you actually need it, maybe it has some dramatic rippling effect. It's something that is very hard to retrofit and will generate a lot of what people nowadays call refactoring, which last century was called scrap and rework. Okay, so weaving functional and architectural stuff over relatively small iterations. All this is a preamble for me to bring a more complex story. And what we've been speaking about until now is the top of this little dark triangle, the architecture of the system. And the architecture of the system, what we've come to know is that we can use multiple views. There's a static view at the structure of the code. There's a dynamic view, what are the multiple concurrent threads and how do they communicate and how do threads or processes come to life and die and block each other and whatever. And there is the structure of the system, how it is deployed. So we understand that. There is the structure of the development organization. That's another structure. Well, if you're 5 guys around one single table in Montreal, like my son 3 years ago, the structure is pretty flat and you can just shout at each other. You don't need to do a daily stand-up meeting because you're 5 guys around the table. Sorry, there were no girls in that team. They have some now, but not that many. But then there is the infrastructure that is used in production. That's another structure that is interesting. Now that structure may have been described or sketched by the architecture of the system, but the development of the system is usually done in a much simpler context. Yes, we try to have test harnesses and things like that that are representative of the real system. But if you're a developer at Bell Mobility, like one of my kids was, yeah, you have a few things in the lab to try your stuff. The operational system is made of thousands of base stations spread across Canada. Well, not too many on this part of Canada, but on their part. And things go wrong when it goes into operation. So there are actually 3 words ending into the architecture of the system, the structure of the organization, how we organize in teams, and how those teams communicate, and what kind of structure do they have. Is each team relatively flat, self-organizing, good agile team, or is it very hierarchical? Are the teams of a totally different nature to whom we hand over things? There's a release team, and there's a testing team, and there's a QA team. And in some cases, there's the people building the hardware. If you're building your own hardware, few people have been doing that. And then, as I said, the production infrastructure. So these structures, they evolve over time. The architecture of the system will evolve. It will evolve until you get release 1, but after that it will continue to evolve. If you're successful, it's more likely to evolve than if you're not successful, but it still has to evolve. Even a system that doesn't evolve in terms of adding features will have to continue to evolve because its environment evolves. There's a new version of the operating system. There's a new version of that standard for communication with your other world. So this system evolves. This will have to evolve also, the structure of the team. You may have more people, you may start outsourcing part of it. So the structure of the team will evolve. And the production infrastructure will evolve. Sometimes not as fast as the other 2, but they need to be kept aligned. This evolution cannot be done totally independently. So the first one here has been studied over the last 10 years, I would say. It's called Sociotechnical congruence. How do we align the structure of the system with the structure of the team doing the system? Now this is not new. There's a gentleman called Conway who developed Conway's law in a little paper in that Datamation in 1968. I was in grade 12, yeah, something like that. Organizations which design systems are constrained to produce designs which are copies of the communication structures of this organization. Direct quote from his paper. Basically, the kind of example that he gave, which I witnessed myself. If you build an Agile compiler, Agile was a language that was invented in the 60s. If you build an Agile compiler and you have 3 teams, you end up with a 3-pass compiler. For the same language, an organization that organizes themselves in 4 teams, they end up with a 4-pass compiler. So that's Conway's law. And I've seen that reproduced many times, including here in Richmond when I arrived in 1992. There was an organization with subcontractors, and the architecture of the system was exactly a replication of the various subcontractors and their financial and contractual dependencies, which was sort of intriguing and amusing at the beginning. So we have to align, in some ways, the structure with the architecture. But it's not the structure that dictates the architecture. We have to do the inverse of what Conway's law. We have to define a proper architecture or the structure of the system, and then align the team to that architecture. So if the architecture of the system and the structure of the organization are at odds, the structure of the organization wins. That's Ruth Malan. Ruth Malan is a very wise woman who has a very interesting blog on software architecture. The references are at the end of the last slides, and I'll give you again the pointer to where the slides are. Architecture and structure must co-evolve. If you make a dramatic change to your architecture, you probably should at the same time change the structure of the organization, which if you're collocated is easier to do than if you're not collocated. If you have a sort of rigid, we have 3 teams in 3 different cities, that's going to be harder to do. So if you don't align them, the organization will win. That is, you'll get stuck with an architecture that may not do what you want, but it is the way it is because of the organization that develops it. And there's plenty of examples of that. People have studied that very precisely. Siemens in particular, who has development sites all around the world, including some big ones in India, has looked at that with teams working for the same product in Brazil, in India, and in Germany, and in Switzerland. So we know that this is a real problem. The organization has to follow the evolution of the architecture and not the opposite. And if for some reason you don't evolve the structure, the architecture of the system will constantly try to replicate the administrative or people organization. System architects, the architects, and the business organization architects, what we call the managers, should not work as if one has no impact on the other. So we have this social technical congruence that we have to think about. When we build the system initially, then we can organize the structure of the team. But when this evolves, this has to evolve. And if this evolves independently for some reason, this will have some nasty consequence on the architecture. If suddenly you sort of say, oh, this subsystem will have it partly responsible for the people in Hamburg, and the people in Estonia are going to also be responsible for it. They're going to break the code into 2. They're going to invent ways to not step on each other's feet. And that's a case where the architecture will evolve, not to support the system that you want to build, but just to accommodate the people that are working on it. So how do we take care of these 2 other things? So this is where a concept called DevOps appears. So development people develop their stuff, they do all kind of testing, and then when they're done, they throw it over the wall to people in operation who get it and try to deploy it. So when you do that once every 6 months, okay, they know that there will be a little period of instability and a few weekends that are wasted and long nights without sleep, and there's a little bit back and forth. But when the release intervals start to shrink, this became a little bit unsustainable. So what is DevOps? DevOps, I'm going to, the original author of this, actually Patrick Desbois is one of the most visible promoter of DevOps, and actually I think he's the guy who cranked the word, he's a Belgian guy. DevOps is the practice of operation and development engineers participating together in the entire service life cycle, from design, or I would say even from requirements, down to having the software deliver its function to end users or whoever it is. So Patrick Desbois has it in a much shorter sentence. It's a little bit like a Martin Fowler. It's kill the silos. It's not easily done from an administrative perspective. You know, if you are a company like, I don't know, Taylor's or Bell Mobility, things like that, it's not just a matter of the CEO saying, oh, all these people, they should work together. Let's put them on the same floor. Done. You know, there's all kind of political forces, cultural forces, the way people work, even in small companies. So I'm in constant communication with a small company in Montreal. They're small, they're 25 people. they have two ops person, and this ops person have a very, very different mindset than the people in development. I'm not saying that in a negative sense. Their mindset, the way they consider their work, their service to the company is very different, and there's constant clash. So it's good go on, and there's quite a few visible companies who've achieved some significant level of integration between operations and development. So you are a software developer, you're not even the project manager, you're a software developer. You put some code out there, it will be in the hands of the end user in the next hour. And maybe you go home, but you have a pager. If something fails, you're paged. And you come back to work or get to some internet, you fix it. You don't say, oh, operations people will decide what to do, we'll send you a bug fix release next week. It's the developer directly who's in contact with the alarm system that's in there. So one of my other kids here in Vancouver, she's hooked to a system that is on some basement of some building, not too far from here. And when something goes wrong, a cell phone rings. So I've seen her several times. Okay, Dad, sorry, I cannot stay for dinner. I have to go now. Okay, so why do we have this concept of DevOps, which is only slowly emerging, and it may take different names? The test environment on the development side is not representative of the real deployment. That's one of the key issues. So basically, rather than testing on some relatively artificial, narrow thing, just do things in small increments with very fast way of backing off. That is reverting to the last working version, meaning an hour ago, and then working to fix the problem and re-injecting the software. There's also a lot of issues when there is a heavy data conversion and transfer of data from one version of the system to the other ones. So this seems to imply that you have a relatively stable architecture. You're not going to do some massive change in the architecture and just deploy them just like that. Many systems need continuity of operation. You cannot stop. You cannot stop. Well, you may stop maybe for an hour if you're lucky, but you cannot stop all operation for several hours or several days. And maybe even if you stop for an hour, you only stop for a fraction of your services. The rest continues, a fraction of your services, and you observe how the system works. Not you observe, not human beings, but supported by tools. And if there is no major issue, then gradually the rest of the system gets the new update. And then you continue the cycle a few hours later. So continuous release is something that quite a few companies now have achieved. I heard recently spectacular presentation by people at LinkedIn, Netflix, Amazon, Facebook, despite the whole thing being PHP, which throws me off. I have a hard time maintaining 100 lines of PHP in this machine for a little website buddies of mine, so I don't understand how people can manage 500,000 lines of PHP. But okay. It also plays a big role in retention of personal and knowledge. That's on a totally different plane. For the companies that have been successful in going to the DevOps model, they feel that people feel much more empowered. There's no fracturing of the knowledge, where people have their little silo and they know specific things that the other party do not know. And I'm speaking about both parties, development and operation. And people feel much more valued in their work. So, and that rhymes very well with the Agile philosophy and sustainable pace and all that kind of thing. So what implication does this has on architecture? It means that the architectural concern, the operational concerns have to be taken into account pretty early. Which means that the architects cannot just look at technology, anything like that. They have to work in operations. They have to really get to understand what's going on in operations. People also think that in order to do that elegantly, you need to go to some kind of a microservice-oriented architecture, breaking down to really small services that can evolve more or less autonomously as long as you don't change too many interfaces. Two gentlemen, Pierre Purer at Travelers, which is a big insurance company, and Murat Herder at Deutsche Bank, big bank in Europe. Even looking at sort of continuous architecture. It's not just continuous delivery, but they try to bring this notion that we can do things continuously at the level of continuous architecture. They are, oops, sorry, there's a strange word, amiable. They have a book that they're building under our very eyes on our WordPress blog, which unfortunately, it's in the reference. It's PGP. I don't know why. I think it must be the initials of Pierre Purer. It must be Pierre Gabriel Purer or something like that. And PGP was taken already, so we made PGP. It'll end up in a book, but right now we can read several of the chapters there. Another avenue there is using what the Software Engineering Institute called tactics. Tactics is a way to approach a certain design issue. It's not as concrete as a pattern, although you could implement certain tactics as patterns, but there's sort of a catalog of certain issues that you can go through to help you reasoning about architecture and other design things. So a tactic is a sort of hypothesis that you're going to validate by implementation or using some ready-made code and things like that. So patterns, frameworks, they are concrete packages for certain tactics. So for instance, you need high availability in your system. Well, one tactic is redundancy. So that's how to attain some high availability. Now, with that comes some questions. And which kind of redundancy gives me the level of availability that I need, or maybe I need to look for something different, or maybe it's out of reach, sort of financially or something like that. And then I can maybe find some pattern in order to achieve this redundancy, or even some ready-made code. So architects use catalogs of tactics. So there are some tactics for availability, for interoperability, modifiability, performance, security, testability, usability. So deployability tactics, for instance, which is important to go rapidly into operation. Parameterization, self-monitoring, self-initiated version update. So that's tactics that you can look at as possible alternatives when you're doing architectural design. And each one of them may have some concrete implementation or not. And if it's the way you want to follow and it has no concrete implementation that fits into your context, then you have to do some software development. So if I look at the various interfaces between my three tures, architecture, structure, and infrastructure, there are different tactics that I can use. Between the architecture and the structure of the team, things like congruence and coordination, different ways of decomposing the system. So there are sort of guides for the architect or the team that develops the architecture, if they're not called architect, as to what are the issues to consider and what are possible avenues for them. So tactics is a possible approach there, and a gentleman called Len Bass, who with two other colleagues, Liming Zhu and Ingo Weber, is also writing a book that we can consult as they build it on architecture and deployment. His name is Len Bass, and he's a former member of the architecture group at the Software Engineering Institute, but now he lives in Sydney. My buddy and longtime colleague, Grady Booch, wrote this a long time ago. Actually, it was at a conference in Vancouver in '98, I think. XA 98. There's still much friction in the process of crafting complex software. the goal of creating quality software in a repeatable and sustainable manner remains elusive to many organizations, especially those who are driven to develop in internet time. So at Rational Software, we use the word friction a lot to describe anything that slows down. And it may be inside the code, it may be the way the code is organized, and also at the architecture level. It may be also people and organization and the communication means. So friction, it's the resistance that, when you try to make things move, it doesn't move as fast as you want, even if you push harder. So in software development, it's whichever phenomena is resisting progress, limits, constrain the progress. So it reduces your velocity, if that's the word you want to use, or productivity, if you were like me raised in the previous century. Technical debt is certainly one main cause of friction, especially at the architectural level. But there is another form of friction. It's called social debt. What is social debt? Well, pretty much like what technical debt is, the negative consequence of the suboptimal decision that we've taken in the past, and we suffer from them now by being slower, having a hard time to evolve and adapt. While social debt is about the same thing. It's the state in which you are when you have to suffer all the consequences of the decision that you made at the organization level. Who you hire, how they're located, what kind of environment do they work in, which kind of process do they use. Are you self-organizing or command and control, compensation, all those things. Some of them have positive impact, some of them have negative impact. Some of them are in the structure, how we get organized to communicate and make decisions, things like that. And there is a part of it that is, social debt. Yes, we've made a certain number of decisions. They were optimal at the time we took them, but now we are 6 years later or 6 months later, and they are really suboptimal. But we tend to sort of say, oh, well, it's like that, and we don't want to change it. And we don't want to shuffle things, and we don't want Joe to feel like he's been demoted, and we want to make sure that Sam over there is happy working with Mary, and so on. But all these little decisions, they end up being like, death by 1,000 cuts. So the same thing that happens at the architectural level with technical debt, we see it also at the structure of the team, the social aspect. So I've been looking at that with a young Italian called Damian Tamburi and two of my buddies when I was in Amsterdam for a year recently. So social debt, it's the decision that you've made about the organizational structure, the process, the governance of the project, the social interaction, including the tools to support these social interactions. And I made in this audience a couple of times a presentation about technical debt with my 4 quadrants. So this is technical debt. It's the stuff that has negative value and is invisible. You want to maximize this, you want to minimize this. This is hidden, this is architecture. It takes some effort to do, it has some value, but that value is not visible. And technical debt, same thing. It has negative value and it's invisible. Similarly, social debt has the same pattern. I can organize, anti-patterns in organization and sort them, patterns and anti-patterns, and sort them across the same aspect. Okay, let's get to a conclusion there. I have 1 more minute. I wrote a few months ago a tongue-in-cheek paper in the Cutter Consortium magazine called How to Agilely Architect an Agile Architecture. Architecture, it's not big up from design. It's not bad. It's not anti-agile. Architecture is software development. It just focuses on a certain class of design decisions. Which ones? The ones that will be hard to change later. The stuff that's pretty hard. And maybe they've been taken already, and maybe you're pretty happy with them and you don't need to worry. Design your architecture incrementally. It's not big up from design. You know, you can do that in iteration. It requires a little bit of imagination. It requires to understand dependencies. It requires some work, but it can be done incrementally and use this sort of zipper model that I described briefly earlier. You need to repay your technical debt early. You cannot sort of say, oh, well, we can do another release without to have to change that. There's a point at which the interest that you pay on the debt will exceed the benefits of developing something and getting to market early. I've seen organizations, there's a very nice mapping company in Europe that was bought by Jepson recently. They have so much technical debt. The product is fine, great products, people love them, so that's not the issue. But they have so much technical debt that any small change takes them an enormous amount of time because they have about 4 million lines of code and only a few people understand all the dependencies. And as soon as they touch one thing, something else breaks somewhere else, and the testing is massive because a lot of the testing cannot be automated. So repay your architectural debt as much as you can. And align the organization constantly to match the architecture as it stands now, not the architecture that you had 6 months ago or 6 years ago. And companies tend to freeze the organization, and people are comfortable and they belong to that team and they don't like to change. I worked for 17 years for a company, Rational Software, where we had relatively few fixed teams. People complain, oh, there's a reorganization. We were in sort of constant reorganization. We were constantly fluid. Now, this was a little bit limited by the fact that we started to be on different geography. You know, I had a team in Vancouver, but it change to adapt to the current situation must be percolated to the team level and the role of the individuals. Besides that, use all the agile practices that you may see fit, which means not all of them, the ones that help you. I see still too much dogma, you know, we are using XP and Scrum or both, and we have to do this, and if you don't do a daily stand-up meeting, you're not agile. Okay, we're in 2014, we have to get a little bit out of the dogma. Agile practices, they're all good. They're not best practices, they're all good. They're good in a certain context. And your context may not be the best one to use this or that practice, including the ones that everybody claim are the fundamental ones in agile development. And by the way, they disagree on which one they are. Depends who you speak to. Few things to reduce friction, keep them aligned over time. DevOps may not be for you, but at least you need to keep the things relatively well aligned. And this is done by communication. So if you repeat my slides, I have put references and pointers to the very thing. I noted that you were trying to scribble them down. The slides are here. So Philippe, there's only one L. It comes from July in Greek, and that's Hippos, the horse. Kruchten, it's a little village in Luxembourg. Sorry, I don't know where it comes from. And the T is after the CH. It's not Kruchten. It's Kruchten. Right. Questions? Yes, sir.
Sort of a comment on friction. I'm a bike rider, and parts of my bike, I don't want friction. The parts of the riding, I need friction. If there's no friction, I wouldn't be able to ride a bike. And I'm wondering if, in terms of organization, if you want to have some friction, some things that are not changing. Otherwise, if everything is frictionless, you'll just be sliding all over the place.
Well, it depends. If you want to go in a certain direction, it's not necessarily friction, it's guides. That you need. Yeah? Okay, but I'll think about it. Yeah, it's an analogy, okay? I spared you the quote from Clausewitz about war, from his book On War, where he describes friction. But yeah, your point is well taken. Yes? No, you.
I noticed your slide around, you had the one slide that looked like a tree on its side.
Yeah.
And I have a question on the what you call sociotechnical
congruence.
congruence.
Yeah.
And there's sort of a decision that you have to make around whether you're going to cohere with layers or with slices for your architecture. And I noticed your slide was ambivalent about it.
Yeah, no, because tactics are not the choice. They're all the alternatives that you try to enumerate. And yes, you can organize things where you have certain functionality that cross across multiple parts of your software, and you may want to organize a team across that, and they'll touch many parts of the software, or you want to have more vertical stuff. That is, you're responsible for this type of functionality, but deep down across things, or some combination of both.
So
This would require a whole hour in itself, how do you slice the stuff so that you can distribute it and minimize the amount of communication and collaboration and the amount of rippling effect of doing changes. But I'm just saying that tree just shows that there are alternatives, and they're not necessarily mutually exclusive. You may take two tactics and combine them.
And related note, do you have any thoughts about how you can organize your architecture and your teams so that you can have a very wide, complex user interface, which so it might have many features, and from my perspective, I sort of want teams aligned with those features, but I want a coherent user interface that they all work within.
Guidelines, education, static checkers. If you partition it across 3 teams, but you want some uniformity, you may have this uniformity by having somebody that will be responsible to go across and do design reviews and code reviews and promote some guidelines and do little tutorials for the newcomers. But also you may encapsulate that in some tools to check that certain design rules about your user interface are enforced across. And then you can be more confident that the people working in the sort of vertical silos will end up having something that is relatively coherent. I'm just shooting from the hip there. I haven't really thought fully about your question.
So I'm going to ask another question.
Yeah.
But,
Can I get you to hold a second?
Yeah, sorry.
Yeah, don't mind.
I'll
The next event's the panel next door at 3.
Starting in 7 minutes.
Yeah, so.
So
maybe
Okay,
we
I'm-
should wrap up.
I'm hanging around and
Yeah,
here until
that's right.
7:30, so we can
That's
continue
what I
the
was gonna
discussion
suggest.
over a
If
glass of
anyone
water.
has more questions for Lee, then, by all means.
And my offer to discuss further is offered to all of you, not just
There
to
you
the
go.
gentleman.
Anyway, thank you very much, very interesting talk.